The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Abacus Division Setting Quotient. In the earlier video, we mentioned that in a division problem, the divisor should be kept at the extreme left of the abacus and the dividend is set in the extreme right of the abacus. It is always useful to compare the guidelines that we adopt in various abacus operations. In multiplication, we make a calculation of where to set the multiplicand in the abacus, whereas in the abacus division, we make adjustments on where to set the quotient. In example 63 divided by 7, the divisor is set in the extreme left of the abacus and the dividend 63 is set in the extreme right of the abacus. We get 9 as the quotient and the question is where to set it in the abacus. Regarding this, there are some general guidelines that the child should be aware of. If the divisor is equal to or smaller than the first digit of the dividend, we have to skip one column to the left of the highest digit of the dividend and set the first digit of the quotient there. If the divisor is greater than the first digit of the dividend, then there is no need to skip one column to the left of the dividend. You can place the quotient to the immediate left of the dividend. In divisions dealing with the higher numbers, you will get the quotient, which is a multiple digit number, and you need additional columns for setting the other digits of the quotient. In such cases, you will be setting the digit of the highest column first, and then the remaining digits should be placed in the consecutive right of the previous digits of the quotient. In abacus division, we will be reducing the numbers in the dividend at every stage of division, and therefore it will automatically clear ways for setting the additional digits of the quotient. When the setting of the dividend and the quotient are correct, the remainder of the division problem, if any, will appear in the appropriate units, tens, 100 columns and so on in the abacus. These may look like abstract concepts, but they are not complicated. Let us demonstrate this with an example in the next video.